So in this video here, we're going to see how we can do post estimation on a construction site. So we're basically just going to run through a bunch of different examples for construction sites. We want to have construction workers do post estimation on top of that to prevent health. By doing that, we can go in and monitor the workers' health, but also different positions and so on that they're performing while working, but also just preventing injuries in general. We can apply fall detection and so on top of it, but it's really important to do human post estimation on construction sites, and it can be really helpful for a bunch of different use cases. So let's just jump into it. Let's see how we can do it with the YOLOv8 model. So we're just jump straight into the Ultralytics documentation. If we go inside the task tab up here at the top, we'll be able to see all the different tasks that we can perform with the Ultralytics framework and the YOLOv8 model. We only need to specify the model file that we want to use, and the whole framework is going to take care of the rest. If you're running it for the first time, it's going to download the model automatically and everything. So you can both do object detection, segmentation, classification, post estimation, and earn it bounding boxes, but we have videos covering all the tasks in here. So if you take a look at the post estimation, this can be really helpful for construction sites. So we'll say that you have like a CCTV camera monitoring different workers at the construction site. Could be for PPE, could also just be for detecting different positions and so on that the workers are performing. Could be that they shouldn't be performing specific operations or specific lift and so on, depending on their poses. So from the post estimation, we'll get all these key points and also features. So it could be like the shoulder joint, elbow, hand, knees, and all of that. All of it is basically connected into a skeleton or stick figure, which you can apply analysis on top of. So we have all the variations here of the YOLO models for post estimation. You just have to specify this dash post after the version and also the model variation that you want to use. If you scroll a bit further down, you can also go in and fine tune it, do validation and do prediction. So this is pretty much what we're going to do. So we just copy paste this code here. Let's jump into a code editor and see how it works. Test it out on a few video examples from construction sites. So first of all, here we just import YOLO from Ultralytics. We specify the post estimation model we want to use. Right now we're going to go with YOLOv8, the nano version. So there's the smallest of the YOLOv8 models, and we just specify dash post. There we go. We're pretty much good to go now. Now we can go down and call the predict function or just throw it directly into our model. I have a bunch of videos here that we're going to throw through. You can specify if you want to show the results. You can also go in and save the video file. You just need to specify save equal to true, and it will then save a video file that you can then show off and get the results afterwards. So right now, this is pretty much everything that you have to do with the Ultralytics frameworks. Then you can always apply analytics on top of it. You can extract all the key points, the poses and so on directly from this results variable with both the bounding boxes. You will also get a bounding box around each person that we're detecting. But we have these videos that we're just going to pass through. So here we just have 2 workers at a construction site, which are basically like wearing PPE. Then we're going to do post estimation so we can take the different poses. They should be good in this example here, but again, just to show that we're able to do post estimation with very high accuracy. We also have another video example here that we're just going to run through. So some different examples where they're moving the arms a bit more. So we're going to see if the post estimation model is able to do that, but also in scenarios where the full body is not covered in the video frame. The last one here is basically just some construction workers doing actual like work. They have different positions and so on. So it's going to see if the post estimation model is able to detect all those scenarios. You can always test out a larger version if you're not getting satisfied results. So we just throw in the workers video. This is the first one that we're going to run through. I'm going to open a new terminal, activate my content environment. And again, this is just a single code file, a few lines of code, and you have everything up and running, and you can specify any source in here. Even if you have an RGPS stream at your construction site, at your factory or production plant, you can just specify the RGPS stream directly in here, and it's going to run it on top of that if you just want to test it out as fast as possible before doing any analysis on top of it or developing a whole system around it. So we have this Python 3.9 environment. There we go, and we can just run the Python script directly. So construction_post.py. We're good to go. It's going to download the model automatically if you're running it for the first time, and then it will both show the inference results and save a video. So this is just running on a CPU right now. It is around 70 milliseconds, so that is actually like pretty decent. Here we can see we get some pretty good results. We can probably do some filtering. We saw we got a detection here to the left, but it is with a low confidence score, so around like 0.25, 0.30, so that will be easily filtered out with just a threshold value. But the other two persons here, we can see it does a pretty good job with the post estimation of the nano model. It even tries to estimate the feet of this guy here, even though they are occluded. You see the left one here, all the shoulders, we get the hips, we get the knees, the ankles, hands, and even the eyes and nose, and also the ear key point. Everything is combined into this skeleton. Let's go in, test some of the other examples out. So the only thing that you have to do is just swap out the path. So we have construction. There we go. And we can just rerun our Python script. There we go. And we can see it can even estimate the poses, even though it can't see the legs, but it still detects the hips here. Let's see when he moves his arm. We still got the elbow, even the hand, and even the bended one over here. Pretty nice. You can go in, extract the key points, use this to monitor the health or like the different poses for the construction workers, but also just for preventing injuries from different poses, fall detection and so on. If the key points are basically just collapsing, different angles, you can calculate the angles in between all the key points and so on as well. So yeah, let's go in and test the last example here before we round off the video. So that is the PPE example. That is a pretty cool one because then we can see act like workers doing work, testing it out, seeing if it can act like do post estimation, even though some of the workers are occluded. So here we see it does a pretty good job. The hands are moving, doing something here on the wall. We have a bunch of persons here that basically just standing on top of each other, but the post estimation model is still able to get the detections. It has some problems here with the hands. Again, they're both wearing like gloves, long sleeves and so on, so that might be a bit harder, but it actually did a pretty good job at estimating that. All the results here will be saved into the runs directory, so you can go inside of that, take the video file, even take the model and so on. Everything will be automatically downloaded. 2 lines of code, that's all you need to have this post estimation up and running for construction use cases. Test it out directly on your own, and then I hope to see you guys in one of the upcoming videos. Until then, happy learning.